Hey you all. So we're going to finish up section 1.4. Let me get my pointer. We're looking at the last set of these, and they are based on actually the equation from the unit circle. They show you how you get these identities in the book on page 36 and 37. But to keep this brief, I'm not going to do that proof to show you that here. But I will do it in class, and or if you just want to see it on your own. So what we have, again, they're based on the unit circle, which is another form of the Pythagorean theorem for a radius of 1. We get these three, and you can see something squared plus something squared is equal to 1. So it looks kind of like our unit circle formula. Okay. So these three, okay, I can replace cosine squared plus sine squared with 1. I can replace secant squared with this. I can replace cosecant squared with this. Now over here, all this is we solved this equation for cosine and took the square root on both sides. And took the equation, solved it for sine squared, and then took the square root on both sides. And remember, when you take the square root of something that's been squared, you have two possibilities, a positive or negative, but due to the constraints of the problem, you may have to rule one of those out. Okay. The other thing to note is this expression sine squared, okay, means I just square whatever the value was for sine. So if sine is 2, then sine squared is going to be 4. Same with the other functions. Okay. You do want to commit these to memory, but the more you practice and how, if you know where it comes from, it really helps you to remember. So let's look at a problem using the identity. So our example problem says if cosine's a half and theta terminates in quadrant 4, find the remaining trig ratios for theta. Okay. So we know cosine is positive 1/2, and the easiest one to find is its reciprocal. So I can go ahead and just reciprocate cosine to get secant. So by turning 1/2 upside down, I get 2. Okay. Now, having cosine just by itself or secant just by itself won't get me to sine. But cosine squared will get me to sine because of the Pythagorean identity. In fact, it's this one right here. But we're going to have to determine, as always, which sign is going to be used because of the conditions we're given. Okay? So we have cosine's positive, but we're in quadrant 4. So sine in quadrant 4 is negative. Okay. Only cosine and secant will be positive. Okay, so we'll use this identity to find the value for sine. So I'm going to go ahead and put a negative in front of it because I know that the angle's in quadrant 4. Then I'm going to replace cosine with a half and start simplifying here. So a half squared is a fourth. 1 minus a fourth is 3/4. And then I want to simplify this. You don't want to leave a fraction under a radical. So I just break up the radical to the top and the bottom. The square root of 4 is 2. Okay, so now I know what sine is. So we know cosine's a half. Secant's 2 because it's a reciprocal. And sine is radical 3, negative radical 3 over 2 because of the Pythagorean identity. Now the next easiest one would be to find the reciprocal of sine. And the reciprocal of sine is cosecant. Okay? So cosecant is going to be negative 2 over radical 3, the reciprocal of this. But then I went ahead and rationalized the denominator. Okay, now finally, we have to find tangent and cotangent. And since we know sine and cosine, we can use this ratio identity, that tangent is sine over cosine. So if I take negative radical 3 over 2 divided by 1/2, that turns out to be, remember when we divide fractions, we change the operation of multiplication, we reciprocate the 1/2, the second one, and then we multiply them together. And the 2's will cancel, and I just get negative radical 3. The last one to find is cotangent. And since I know tangent, I could go back and use a reciprocal identity, a ratio identity, but I might as well use the reciprocal identity. Cotangent's the reciprocal of tangent. Okay? So, cotangent theta is going to be 1 over radical 3 negative. But I went ahead and rationalized the denominator, and I have negative radical 3 over 3. Okay, so now we know. Take a little break first before you start working. And there are some problems to work. And if you need to refresh your memory, go through the slides again. Remember that math is meant to be studied in short, intense bursts, because your mind gets too tired if you work on it for hours and hours and hours. So give yourself breaks, come back and work, and if you get stuck, please email me. See you all in class.